Right. We need to know about the different types of power station. Other than the standard power station, that burns coal or oil or gas, we need to know about other types. So we're going to start here with wind, and basically what happens here is the wind turns the blades there, and they're connected straight into a generator. There's no turbine here. I suppose the turbine is the massive propellers there, and it causes the magnet inside the generator to spin around. It's good because there's no carbon dioxide produced, and it actually gives us quite a lot of energy. When it's windy, we can produce 15 to 20% of our power in this country by wind. But of course, if there's no wind, there's no power, and that is a big problem with it. Wave power tends to work by having things floating in the sea, and when these things rise and fall with the waves coming in, the kinetic energy of the waves tends to sometimes perhaps push air into a container and into a device, and that as the air goes through something, it can turn a propeller, which is then connected to a generator. Or sometimes just the rocking motion can actually be connected to a generator, and that can create voltage as well. The big problem with it is that they can be damaged by storms and shipping, and they're perhaps a bit of an eyesore as well. Hydroelectric is proven technology, works very well. The problem with that, of course, is you've got to flood valleys, and if a dam bursts, there's a bit of a problem, but that's very, very rare that happens. Hydroelectric, it obviously doesn't contribute to the greenhouse effect because it doesn't really save any carbon dioxide, apart from when you build it. When you build it, you use cement, and making cement and concrete releases carbon dioxide. Tidal power is a bit like a dam, but instead what you do is you use the water coming in and out during the course of a day, and it works 4 times a day. So for one part of the day, the water's going from left to right, and then as the tide falls, the water goes from right to left, so you can catch the water going in and out 4 times a day from tidal power. It generates a lot of power, but the problem is it alters the local environment. Silt starts to build up behind the dam, and perhaps you might damage places for birds to live, for example. A good example of a tidal power station is they're building one in Swansea Bay in Cardiff right now, I believe, and people have often said that we could probably do it at the Severn Estuary as well, between Bristol and Wales. Pump storage is one to be very, very aware of. What we have here is we've got a lake at the top of a hill, and then we have another lake at the bottom of a hill at 2, and that little square there is actually a power station inside the hill. It's pretty cool. And so what actually happens is that when you've got when you need power quickly, you can allow the water to go from 1 to 2, and that generates a lot of electricity. But at times of the day, actually at night basically, when you've got loads of power stations chucking out electricity that no one wants to use, you can use that electricity to push the water up from 2 back up to 1, so that you can use the electricity later on. So essentially it's like a massive battery. You're storing energy, and that's why it's called pump storage. Geothermal power, this is a geothermal power station, works by drilling a hole down into rocks, and these rocks have to be very, very hot. So you tend to put these in volcanic areas, and normally what they do at this point here is when they've drilled a hole down, they put explosives in there to shatter the rocks, and then you pump cold water down one pipe, and as it goes through the cracks in the rock, it gets heated up, it boils, and the steam goes up the other tube, and when it goes up the other tube, it goes through a turbine which is connected to a generator and makes electricity. So you can do this in places with volcanic activity. And finally, solar power. Solar power comes in 3 forms here. Let's have a look at the first one. A solar furnace, and this is what they have lots of in Spain, is they have loads and loads of mirrors, sometimes thousands of mirrors, reflecting the sun's light and heat onto a box. And inside that box, there will be loads of water, and the water will boil, and then, of course, the steam will then drive a turbine and so forth. That's a very common thing in Spain at the moment. Solar panels basically take light and change that into hot water, they take the light from the sun and they use that to heat hot water pipes. There is a video explaining that, how solar panels work. And the third example of solar power is things called PV cells. These are the things that you see more and more, where people have got these things on their roofs and they change light into electricity. They tend to be quite expensive, and of course if there's no light at night, for example, you're not making electricity. So that's solar panels. Anyway, there we go. There's the different types of power station that you may meet in the exam.